Greetings and welcome, friends. Today, we're continuing our investigation, if you will, of roots of real numbers. I still haven't addressed the fact that there are numbers that aren't real, but don't worry about that. Actually, let's take a look again at this. Oh dear. Oh dear. Oh dear. Oh dear. There it is. Haha. Let's look at this example. I think I showed this example yesterday, and I left an answer that was technically somewhat unsatisfactory. Ah, yes. So it's left us somewhat concerned. And perhaps you even noticed on the previous quest that there were some problems that you weren't getting quite the same answers to. So what I want us to consider is the polarity or the sign, the positivity slash negativity of our variable here. Now, when I talk about just plain old x, all right, let's analyze this x. Could x have been positive? Yeah. Could x have been negative? Yeah. Could x have been 0? Sure, it could have, right? I'm just going to focus on positive or negative right now, but yeah, x could be 0 as well, right? So do you agree x could have been plus or minus, right? Either of those things. So x squared, what happens when I square a positive number? I get a
negative.
Positive number. What happens when I square a negative number? I still get a positive number. So x squared would have been positive, right? Okay, all right. And then if I ask you what the square root of x squared was, well, I already know that x squared is positive, so what happens when I square root a positive number?
Square squared becomes negative. No, it's positive.
It's actually required to be positive here because I've already limited it to being positive, and it'd be like the square root and the square cancel out, and I would end up with a positive outcome. So it turns out when I ask what the square root of x squared is, yes, the square root and the square kind of cancel each other out, so to speak, and I get x, but I'm not correct if I indicate that x is the answer. Because what happens if x was originally negative? Because the square root of x, or square root of x squared is now going to be positive. So I technically will never get a negative answer from this. So in order to restrict that possibility, I'm going to throw some absolute value symbols over the expression. So that way I indicate that I'm only ever going to get positive answers from this. Okay? So that's kind of what we got going on. So I've got absolute value showing up because this can never give a negative. In fact, some books, little side note here, some books define the absolute value of x as equaling the square root of x squared. All right, some books do define abs val that way, which I think is kind of a weird definition. It's true. I think it's maybe more of a property or a fact maybe, but I don't think it's necessarily sufficient as a definition, or not intuitive to say the least. So let's look at another example here. Another example coming at you. This is a promotional song about examples. Here we are. So if I want to simplify the cubed root of x cubed, all right, let's consider this. Let's think about the polarity once again. Little old x, before anything happened to it. Calm down just a minute. Don't you worry. Just wait. Let's analyze a little bit first. So x could have been positive or negative. Agreed?
Yeah.
Yes. X cubed, what about that? If I cube a positive number, I get a positive number. If I cube a negative number, I get a negative, actually. Yeah. Right, because, for instance, negative 2 all cubed just means negative 2 times negative 2 times negative 2. Two of those negatives would pair up, but then one would still be left, so I'd get negative 8s. So it's possible to get a negative out of cubing something. All right. So if I cubed root a number, let's say that I cubed root a positive. What's the cubed root of a positive number? Positive. What's the cubed root of a negative number? negative. So it turns out this one would allow either a positive or a negative answer when I take the cubed root of x cubed. And not only that, it actually would line up with the original values of x, right? So for instance, when if x was originally positive, the answer would be positive. If x was originally negative, the answer would be negative. It wouldn't have been like an opposite situation going on here. So the cubed root of x cubed is going to equal x, because the cubed root and the cube cancel out. And I do fully intend on people interpreting this as whatever your x was when you started, that's what it is right now, because it could also include the negatives. All right? So nothing too crazy just yet. Let's consider one more case and then see if we can make a generality about it. Exactly, because it could be positive or negative there, as opposed to the previous sample where this answer is never negative. Never. 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 So, how about this one? X, let's consider polarity again. Could have been positive or negative. What happens when I raise it to the fourth power? It is positive, because I'd have an e, right? If it's positive and I raise it to the fourth, it's positive. If it's negative and I raise it to the fourth, think about negative times a negative times a negative times a negative. That almost looks like Morse code. These two negatives would become friends and they'd become positive, and then these two negatives would become friends and they'd become positive, and a positive times a positive is a positive, right? So it would be a wonderful day, right? So it's positive. So if I fourth root a positive number, what do I get? A positive. And in fact, if I even tried to fourth root a negative, I would just cry, right? Because
Just be no.
it would just be no. At this point anyway. Maybe I'm foreshadowing too much. I don't want to give anything away. I don't want to tell you what the smoke monster is just yet. So the fourth root of x to the fourth, right? The fourth root and the fourth power cancel out the exponent in the index, right? Kind of undo each other, and I'd get x. But I'm only interested in the positive answers, so I'm going to restrict that to being just the absolute value of x, because it will never equal a negative. So now looking at these three examples, could someone generalize when do you think absolute value shows up and when do you think no absolute value shows up? Okay, I'm going to take that a little bit further, but I do agree so far. And what part are you referring to as being an even number? The index. So if the index is even, okay, then there's going to be an absolute value showing up. In fact, it's a little bit more detailed than that, but that's still, based on the samples that we did, I agree that that would be your initial conclusion. It turns out, this is what I just decided to give this a name today, radicals of variables rule. We could also call this Morgan's rule if we wanted, since right, she was just developing it there. If an exponent and index are even, then the radical's answer needs absolute value. Absolutely. Definitely. So that's kind of our general strategy. So if I've got the sixth root of x to the sixth, what would that equal?
It would equal absolute value of x.
Absolute value of x. If I've got the 21st root of x to the 21st, plain old x, because it would allow negatives. If I've got the googolth root of x to the googolth, like you guys are wondering whether Google is even or odd.
It's just going to be x.
Google would be even because it's 10 to the 100th power, and then yeah, so it would be even because it would just be like one with a whole bunch of zeros.
Is it an actual number?
Yeah, Googol. Yeah, Google, right? Which yeah, so the website company took that concept.
Go write that on the board for us. How many zeros it has?
No thanks. No thanks.
That board?
Google?
Yeah.
Nah. We're good. You could just Google it
How many zeros do you have?
if you really wanted to. How many zeros does Google have? Ask Google. So let's consider this. Let's do an example. So you might be like, Mr. Watt, didn't we just do this example? And I'd say no.
You did it because there's no index of 4.
No index? So this is like 0
No,
or?
I said there's no index of 4. It's 2.
The invisible index is 2. I agree.
Excuse me, why isn't it 1?
We already been over this.
Yeah,
Square root is square.
Yeah, that was in yesterday's video. So this is a square root. So yeah, the index is an invisible 2 is what's going on. So, okay. So the square root of x to the 4th. Now, according to this rule, is absolute value going to show up?
Yes.
Yes, because even, right? Agreed. Now, what is the square root of x to the 4th? Well, I could actually rewrite x to the 4th as a square if you wanted. Ooh, goodness. Why, thank you. And thank you all those commenters that just said bless you in the comments below. Thanks, friends. Let's see, so what's this going to equal? What squared is x to the 4th? X squared, right? So if I square root this will kind of cancel out, right? So to speak. And I would get x squared. Now, absolute values show up. Because why? Because this was even. So absolute value shows up, right? Now, wait a minute. Let's think about this. Is x squared ever going to be negative?
I don't think so.
No, it can't be because it's an even exponent. So a negative number all squared is going to become positive. So this is like saying, oh, by the way, take your positive number and make it positive. And I'd be like, I think you've got some redundancy going on there. So it turns out I can actually drop those absolute values as a result of that redundancy. Okay? That it's if I really want to simplify this, the simplest way would be to write kind of as little as possible, so to speak. And dropping those absolute values would be helpful. Now I agree they had to show up according to this rule. Okay, so they definitely showed up, but then they disappear because they reduced its complexity. So let's consider this example. I am mathing it. So, all right. 6th root of x to the 18th. Now, you could rewrite this as some power of 6, right? But I think you guys are probably getting the idea of the division concept, right? 4 divided by 2 was 2. 18 divided by 6 is going to be 3. So x cubed. Now question, do absolute values show up?
They're supposed to.
Even. So they show up. And now question, do I need them? X cubed can... Right, so x cubed can be negative, so these absolute values are intentional and have to stay there to restrict x cubed from being negative based off of my outcome. Because if x cubed was negative, it would be bad news, lose for us.
Bad news in the kingdom.
Yeah. So in this case, we'll hold. We'll keep those abs in place. Right. All right, let's one more of this concept, and let's see if we can make a generalization here. Example.
It's just the answer in which the exponent does not remain even.
I think I've got someone conspiring a theory.
Unless it's 1.
Well, is 1 odd or even?
Oh yeah.
So here we go. The 4th root of x to the 32nd, what's that going to simplify to be? X to the 8th, because 32 divided by 4. Absolute values show up. Why?
Because they're both even.
Because they're both even. Do absolute values have to stay here?
Nope.
Why?
Because the number is even.
Because the number is even, x to the 8th is always positive, so saying make your positive number positive is a little bit less simple than just saying this. All right. So let's generalize this rule. So when do absolute values stay around and when do they leave?
Abs val stay around when your answer inside absolute value brackets exponent is even, and they leave when the answer inside the absolute value brackets exponent is odd.
I think it was the opposite of that. Although you used a lot of vocabulary there, which was wonderful, actually. I did very much appreciate it. So let's see. So also this name it's not official. I just named it this. We could call it the Taylor-Morrow hypothesis, maybe. I don't know. So if the exponent of a variable in an absolute value is even, drop that absolute value. Yep. Good stuff. Drop that absolute value. Drop it like its temperature was high and you couldn't hold it anymore. As if like the molecules were oscillating at a very high rate, resulting in friction, and then like the expression of energy in the form of temperature.
Okay.
You know, like that's how you would drop it. Like it was hot. You know.
Yeah, like it's hot.
Yes.
I thought I was gonna say in the beginning, and I was like, the temperature is high.
So let's do one last little example here, where we kind of combine our skills. Ba-bum. This is like the boss fight, just like in a video game, where like you're going through the level on like a little side scroller, beat 'em up, and you're like fighting little dudes, and you're like ba psh ba, and like hey, that one has absolute value. Ba psh, no absolute value, and then like we trained with these, like ba, psh, right? And now suddenly like the boss shows up, and it's like, oh, I gotta use all my skills at once. That's kind of what just happened, right? So let's do this. Let's beat this boss fight. And he's all like, and like giant and strong, and you're like, I got this. So, here we go.
Hey, wait.
What's up? Question? No? What?
No, I just want to do it in my head real quick before you do that.
Well, we'll have some chance to practice later. I'm going to explain this to the rest of us, but you can tune me out for a moment. Let's see. Square root of 81, what's that?
9.
9. I agree.
9x to the 6.
I agree. Also, maybe we should ask, what's the index of this square root?
2.
It's a little 2 there. That might be good. Square root of x to the 12th
X to the 6.
is x to the 6th. Do absolute values show up?
No. Actually, yes, they do show.
They show up. All right, we're gonna write it now, and we'll analyze whether they go later on. All right, square root of y to the 20th.
Why is that?
It's y to the 10th. Did absolute value show up? Why did it show up?
Because they're both equal.
Because even.
But do you put a new absolute value?
You could, yeah, you could. Or I could have just like not had this written here, and then yeah, something like that. That's fine.
What if you have one? What if you have 3 absolute values?
That's crazy sauce. Yeah, they come in pairs, man. But that's a good question though. I like it. All right, square root of z to the 17th.
You do the 17th.
17 over 2. Or tell you what, let's break z to the 17th up into the largest exponent that is divisible by 2.
16.
That's z to the 16th times z to the 1st, right?
Oh yeah.
Okay. Do you guys agree that that's still equal to the square root of 7 z to the 17th? Sorry.
Yes.
Yes. All right. So okay. So let's keep working here. 9. Absolute value of x to the 6th. Does that absolute value stay?
Yeah. No. It goes away.
What?
Goes away.
Yes, the 6 is even. Yes, both the x and y, the absolute values go away.
Drop the absolute value because the exponent was even. I like it. Okay. Good. And we do the same with 10 in this case. Okay, drop it. What about this?
That's gonna be 8.
Z to the 8th. Absolute values show up,
But they go away, so.
but they go away, so I wouldn't even bother writing it.
So do you just keep Z to the first?
Yeah, that's still trapped inside. It's like if I went into like the kingdom of square roots and I was like, I've got to liberate all these people, and I was like, get out of here, guys, go, 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 and I went like all Rambo, and then I'm like, I'm sorry, Z to the first, I gotta leave you behind. And he's like, just go, man, just go. And then I'm like running and I'm crying and there's a huge explosion behind me, and it's like, Z to the first, I'll never forget
And then you
you.
just meet again.
Oh, guys, I'm crying now. But anyways, thanks for watching, Internet friends. Have a great day.